Hello everybody, welcome back to this edition of High Tech in the Heartland. I'm Bob Goff, this is Scott Richardson, and before we start, Scott's going to read his disclaimer.
That's right, I'm an attorney, so of course I have a disclaimer. And people that happen to be watching this and hearing my remarks, that doesn't mean any client-attorney relationship is formed. And also, since nobody that's listening to this is my client, I'm not giving legal advice. I'm a patent attorney. I may talk about legal things from time to time, or patent things. And then finally, I work for an East Coast law firm, Bob, Robinson Cole, and I am not representing Robinson Cole in my remarks today. This isn't their official position. I'm just speaking as a private citizen interested in high tech in the heartland.
And we are going to talk about something that's really interesting and very useful and becoming more and more prevalent today, and that's 3D printing.
That's right. Don't we always talk about useful and interesting
We do,
things?
absolutely.
Yeah. 3D printing, but there are like a few broad categories that they're making inroads. Well, first of all, when you think of 3D printing, you think of the printers you can buy like off of Amazon for $300 or $400, and you can't really make a whole lot of useful things out of them. Mostly they make like little kitchen things, like holding spoon holders or cup holders, stuff like that. Although they're very useful for making, like, if you break a part, like a plastic part on your car or something, they're useful for that. But there's biomedical 3D printing, and we're going to talk about some of these in more detail, and then construction and housing, and then also manufacturing. They've made some inroads in manufacturing, and finally aerospace. There's some interesting uses in aerospace for 3D printing.
Okay.
But the biomedical stuff, they claim they can print skin for humans. Now, I don't think they're quite there yet.
Yeah.
It's kind of, they're making inroads though, and they will be there shortly. But anyway, and also, you know, all these technologies are called 3D printing, but they work somewhat different than the 3D printers, you know, like you have at your home. They're going back and forth like zzz.
Right.
For example, they could do 3D printing of metal, but it's almost like wire. It's almost like wire welding if you have a wire welder. They're basically doing a specialized type of wire welding, you know, in a certain pattern to build up a metal piece. And the same with the biomedical, like printing skin. They're not actually printing sheets of skin. They're depositing. They deposit skin cells in a gelatin onto a surface, and there are two ways to do it. They can deposit them right on a person's, you know, hand, and they can deposit them on a surface and then peel that off. It's like a bandage then. And they've done some of that, but they're still in the experimental stages of that.
And as usual, I saw this in Avengers: Age of Ultron.
That's right. You know, those Marvel movies. It's like, I'll tell you what, we should be watching Marvel movies and investing in companies that are making this stuff.
Yes, because it all happens.
They make the Marvel movie, and 10 years later, they're doing it.
Yep, no doubt.
Although, you know, this took longer than 10 years to catch on. The original inventor, Hideo Kodama, invented it supposedly in 1981. And he's from Japan. He applied for a Japanese patent. He got rejected. He didn't get a patent on it. It's like, what the heck?
How do you not get a patent on this?
I know. It's like... That's insane, but that's just the way it is. Sometimes, you know, apparently there were other technologies that were similar to that, and probably failed technologies that didn't catch on. But anyway, he's credited with the inventor. But there's an American, Charles Hull, that came on a few years later, and he's the one that actually came up with working models and popularized it. And he's called the father of 3D printing, Charles Hull.
Okay. When was this again?
1981 was a Japanese fellow, and Charles Hull was in the mid-'80s. I think 1986 is when he kind of came on.
So it's still relatively new technology.
Yeah, well, it took a long time to catch on, because, I mean, I don't think you could buy 3D printers. Could you buy them in 2010?
Boy, I don't think so.
No, I think it's like the last 10 years.
Yeah, I think so. Yeah, and that's where I see more of it now. I mean, you see it online all the time.
Even now, like home 3D printing is kind of, I would say it's kind of in its infancy, because they're really frustrating to use. I mean, they go wrong, and you get it set up, and, you know, leave for the night. You come back in the morning, and it just went wrong, you know, and your whole spool is gone. There's just a big mess.
Yeah, no, I've yet to try to utilize any. I've watched a little bit of online. It's like, yeah, this seems like I'm not a techie guy, and I'm not real handy, but this seems to me like it's something that's even kind of beyond my capability. I'm like, I don't think I can do this.
Yeah, I'll tell you, it would be a fun area to go into to do research on, like a college kid that was going off to study something, like, especially the biomedical stuff sounds pretty interesting, biomedical printing. Because they do, I mentioned the skin, but then also they do They do printing custom orthopedic implants. And for example, when somebody has a head injury, a plate won't fit every head injury, and so they can make a customized piece that'll fit in their skull to, that's just customized for that particular wound. Map it out with imaging, and then.
So when my oldest son he's 30 now, so this would have been 29 years ago, some years ago, we had an accident at the house where I was carrying him and I fell, and I thought I had protected him, but he hit his head on the side of the bed headboard.
Okay.
So, and there was a little dent in his head. And of course, he was very young at the time, like 6 months old, and I was scared to death and terrified.
I bet you got in hot water.
But we were in at my in-laws in St. Louis. So we took him to Children's Hospital.
Okay.
And they took great care of him. And I was just crestfallen. I was just like, oh my God, it's a horrible, horrible thing. And the doctor's like, look, it's okay, it's an accident, you're fine. And what they did was they basically took his skull, went in and just kind of flipped the dent. He was still at the age where his
like a ping pong ball.
Yeah,
right?
yeah. It was so malleable still. They just kind of flipped it. Like they didn't like pop it out, but they
So
flipped
there
it.
actually was a dent in his head.
It was a dent. And I could put my
That is
I could
pretty
put
alarming.
I could put like my thumb in you could feel it. I was like, I just thought, oh my God, he's got brain damage. But he grew up. Now he's a brilliant young man. So
Yeah.
I guess I did something right. I've credited the bonk on the head.
You
for
knocked
making
some
him-
sense into
for
him.
making him the man that he is today. Yes.
Oh, that's pretty funny. But yeah, and in biomed, they not only skin, but they are doing research on and making inroads in printing out cartilage and bone as well. Well, the bone, the orthopedic implants.
Right.
But also they wouldn't necessarily put a piece of bone in your head. They might just put a piece of plastic or metal there that's printed out. And then personalized pharmaceuticals is another area. And when I say personalized, they not only are able to control the drugs that are printed, but also control the release times. Because, for example, some drugs like for epilepsy, they need extremely rapid release times because the person's having a seizure right then, and so they're able to print them out in a manner that has instant effect drugs. They're released instantly. And then one of the other categories I mentioned was construction and housing, and it's kind of cool to see. You can go online and see them build houses.
That's where I've seen it the most, probably.
But also, if you read criticisms of it, you'll read that the houses, are they really 3D printed? Because right now, especially with concrete, because that's basically how it works. Is they're using a big device to lay layers of concrete down, and they'll print like a double wall up, and then with a space in the middle, and they'll inject foam in the middle to insulate it. But the thing is that the criticisms question whether they're actually 3D printed houses because they can't. First of all, they can't print over doorways. Because they need to put a brace in at the right time so they have a place to go over. Because the concrete just fall on the ground if they print it over a doorway. Right. So they have conventional doors and conventional windows, and typically they don't have 3D printed roofs because they need something to hold the concrete up while they're printing it. So that's the criticism of that. But there are actually I guess if you call them 3D houses, there are whole communities of 3D houses. There's a place, Georgetown, Texas, which is it's a suburb of Austin. It has 100 3D printed houses. It'd be kind of fun to visit that, wouldn't it?
I'm planning on going to Austin next year, actually, for a conference.
Yeah.
So yeah, I would like to see that.
I'll bet they have a model house that you could go in and see.
Cool.
Because have you seen them online or anything?
I have, yeah.
The texture, it looks like it looks like those Japanese Zen gardens where they take the rake and rake. I mean, it's they're ridged. And when I first saw that, I thought, oh my God, that would be impossible to keep clean. How could you keep dust from? I mean, you basically have to clean your house with the air compressor, squirt it all off because it's a real rough surface. And I don't know. I don't know if they coat them. They must coat them or something with some kind of plastic or something to keep them so that they can wash them.
Yeah, it's like you'd have to coat it like you would stucco or something on the side of something.
I would imagine.
Yeah.
I don't know. I never read anything about that, but you'd think that they would. But I say that the critics say, well, it's not a true 3D house because they're only doing the walls basically. And if you look at them inside, most of them, the walls don't extend all the way to the ceiling. A lot of them, the walls will only extend up say 8 feet, and then it'll be hollow over the top. So, but there is a company in Italy that 3D prints houses with roofs. And
well, how do they do that?
Well, the name of the company is WASP. That's the name of it. And their technology is based on the Mason Wasp, which basically it deposits materials, and they build their hive, and they go up to. But anyway, that's how they print it out, and it looks like a big. It's shaped like a pine cone kind of, and then there's an open air thing at the top, and then they cover that with a glass.
Okay.
So, but they specialize. They print like. They have a certain. I think they only have one design WASP company at this point, and they print 2 of these things side by side, and then they're broken up in rooms. So
fascinating.
So there's that, and they're doing this in the Netherlands and UK and Germany, Denmark. They're all companies that do 3D housing. So
do we know the cost on any of these?
I saw one place where a guy he was able to get one for $500,000. But I don't know if that's like a standard price or whatever. You'd think it would be cheaper, but I don't know.
You would think.
But that's the only one. I only have one data point, so that's not worth a whole lot.
All right. Small sample size, I get it.
And then another construction thing is off the coast of Ban Rijn, they are building a artificial coral reef. They're 3D printing this coral reef.
Because the coral reef's going away?
Apparently so, yeah. Because, coral reefs get damaged. They probably have a lot of, oil tankers and shipping there, so that's probably the deal. And Ban Rijn, that sounds like an oil money country, so.
It does, yes, most definitely.
And then also another thing is, I mentioned manufacturing. They can make large parts one piece, and like wind turbine blades are made with 3D printing.
Oh, okay.
So I'm not sure.
Those things are massive.
They are. You see them on the highway in trucks, and those trucks are like twice as long as an 18-wheeler.
Yeah, and you see, crazy. When you drive by and you see one there, it's just like, okay, yeah, it's big. But then, when you're seeing, because I think, was it the Weingard company up in Fort Madison, Siemens, I guess those are the manufacturers of them up there in Iowa. And you'll see some coming down there from time to time. Yeah, those things are just huge.
How do they make the corners?
I don't know. Wind turbines is your next one. There you go.
I guess, yeah.
That'd be a really prevalent one for what we've got going on around here. So,
but they make large parts, and then also there's a manufacturing process where it's a hybrid manufacturing process where they do 3D printing, and then they finish it up with CNC to machine it down.
Okay.
But anyway, the 3D printing gets it very close to the shape it needs to be, and then they finish it with the CNC. And it cuts down a lot of waste. They don't have to, like, instead of just doing CNC where they have to carve clear down into they can make the part roughly the right shape and then finish it off. So
okay.
And then let's see, rocket engines. That's like the coolest thing I think I read. I didn't realize till I was kind of looking into this and researching this, but like some rocket engines, they're burning in the combustion chamber at heats of up to 3,500 degrees Kelvin. And at that temperature, that turns iron, that vaporizes iron. That's enough. That's hot enough to melt any metal on Earth, I think.
Okay. Yeah, that sounds like it would be.
And then you think, well, if it can melt any metal, how can they have like the rocket engine?
Right.
But what they do is they have the fuels that they use liquid oxygen, which is cryogenically cooled, and methane, and I think typically methane. But anyway, what they do is those the thrusters, the nozzles. Those aren't actually like solid. Those are just a whole bunch of pipes, like 1,000 pipes welded together, and they run that liquid oxygen through those, through that nozzle assembly, and it keeps it cool. In fact, I saw one guy talking about one of the rockets that he works on, and on the inside, it's hot enough to melt any metal on Earth. But if you put your hand on the outside of it, it freezes your hand. It's freezing on the outside.
Yeah, I would guess it would have to be.
Isn't that crazy?
In order to just keep that so it could be consistent, so you could still keep its consistency while all that heat's going through it.
But what they used to do is they used to actually take real pipes and then they would braze them together and then they would finish the thing, and it would take 9 months to make one, just one, rocket motor. And now with 3D printing, they can make it in 2 weeks.
Wow.
Yeah. Wow.
It's amazing.
That's just crazy. And I think it costs like 10% as much too.
So they're doing rocket engines. Are they doing car engines?
I wondered that. I don't think they are, but it seems like they could.
Why not?
I mean, they certainly could make a lot of parts of them.
Yeah. I would think car parts would be a thing that could definitely be made.
Well, because like the rocket engines I was mentioning with the pipes and stuff, they used to have 1,000 parts that they have to braze all these pipes. Now that it's one piece.
Yeah.
So.
Yeah, because you just do it on the printer and it's all put together for you already. So.
And then another manufacturing thing that they've come up with is like for example, aerospace parts, it's crucial, or anything that goes into space, it's crucial to have a very strong but light weight. And if it's a solid piece, you have to have multiple pieces, welded together or whatever, to make them hollow inside. But with 3D printing, you can print it and you can leave hollow spaces. And one thing that's kind of cool that they're doing is that they're using AI to design them so that they're coming up with new designs for pieces that are lighter.
Okay.
And then also, something that they're using AI to design rocket motors too. There's an AI designed rocket motor that's really, I saw it, it's really a small, just like a copper prototype. And it's a whole new design for a rocket motor.
Do we know how sturdy this stuff is?
Well, it depends on the materials you make it, because you can make stuff from metal.
Right.
And so you can make it as sturdy as you want. But the stuff you print at home, it's kind of,
It's flimsy.
It's really very flimsy, yeah.
And I just don't, I mean, so I'm going to build my 3D house. Do we know, do they stay around forever? How long, do we know if they have an endurance?
Okay,
or?
Right now there's an awful lot of sales puffery in that industry, okay?
Isn't all sales puffery, to be honest?
And the one data point I had, well, yeah, pretty much, that's true. But the one data point I have is that these homes will last 300 years.
300 years.
So, but
okay.
I'm guessing that's probably the walls that they 3D print. Because
right.
I mean, the rest of the house, I mean, my house is 110 years old and it's falling apart.
Right. No, I wouldn't. I'm not going to buy it. Well, I wouldn't be here anyway in 300 years. But I don't think I'm buying.
Yeah, what do you care? I mean, more than 30 years, who cares?
Yeah, that's my kid's problem then. So, what else we got?
Well, I talked about most of the stuff that I was going to talk about. One of the things I was going to give a few more details, like the skin printing, and that's really helpful for burn victims now, because although they're not really printing they can't just slap a piece on and it becomes skin, but they can put these patches on. And they integrate with the body, and they help the healing a great deal more than if they didn't have that.
Okay.
So burn victims are probably the best use of that right now.
That would make sense.
And the way they do that is they take. Well, one of the reasons they haven't been able to do this in the past is that they couldn't use materials that the body wouldn't reject. Like if you use animal cells or other human cells, the body pretty much rejects them. There's a problem with that. But here they can actually harvest cells from the person and use the person's own cells to create, this artificial skin, these patches that are able to, help the healing process. And one way they do that, and it helps if you're a little bit overweight when you're a burn victim, because they go in and they do liposuction and they harvest fat cells, and those are some of the cells that they.
Oh, okay.
And then also they mix in vascular cells, blood vessel cells. Apparently they have to go in and snip those out, but because skin actually has blood vessels in it, very tiny blood vessels, and if you don't print blood vessels in there, it won't. It's just going to die right away.
I would wonder on using 3D printing for plastic surgery. Wonder if there's any application on that.
It seems like
it would seem like that would be like an
3D
obvious,
print a new nose.
Yeah,
or something.
Exactly, right? You'd think that'd be a thing. I would
maybe
think.
Boost up my biceps a little bit. Or something.
Yeah, I would think that's a thing. So.
But the vascular cells, they don't actually print these tiny little blood cells. Vessels. What they do is they mix in the vascular cells in the mix, and then that's mixed in with a gel, a collagen hydrogel. This gel is kind of it's the structure, the skeleton that they're mixing in these different kinds of cells. But they mix in enough vascular cells, and apparently these vascular cells, when you put this patch on, they communicate with each other, and they actually form little blood vessels, just kind of automatically.
And then it just should adapt. And
apparently so. But like I said, that's still in the experimental stage. They're not really, but that's I think that and the rocket motors are the most interesting uses for 3D printing.
Yeah, I would again, the skin, I would think definitely, and I think that would definitely be a thing. And I think plastic surgery seems like an obvious application.
It seems like it would be, but that stuff's kind of a lot more interesting, than soap dishes and stuff you print at home.
that's no fun. So all right, wrap it up.
I think we covered 3D printing about enough.
All right. Wind turbines. I think that's going to be our next one.
Well, we could do wind turbines.
We've got kind of
a cool one.
All right, well, this is going to be our last High Tech in the Heartland for this year. So Merry Christmas, Happy Holidays, Happy New Year, all that great stuff.
You as well, Bob.
And of course, every favorite dad joke in the world. We'll see you next year. Thanks for watching.